Why, hello there, ladies and gentlemen. Let's get rolling. We got a homework 3.2 on the way. We're going to do this one pretty quick, I think. It's a pretty short assignment. But I did want to say that both Mr. Boswick and I agree. You guys did an awesome job today and really put yourselves in position to be successful for the rest of this topic. And we really appreciate that. And if you didn't notice that you guys were working hard, you guys were. And that's amazing. And we love it. So keep up with great work. So anyway, let's jump into the homework. So we have kind of these problems we're doing right at the end of class. Where we have these two matching number puzzles. Two people did them, but one of them is wrong. We have to identify whose is correct and also provide an explanation with example. And that's the part you guys are going to try to cheat out on, I should say. So let's not do that. Let's make sure that we're doing all the parts, explanation with example. So let's check this out. And the way I'm going to kind of first to decide who is right is actually going to be with an example. So we're going to kind of kill two birds with one stone. So this says to write down a number. I'm going to choose 4. Okay, now we have to add 2 to that number, so that's going to be 4 plus 2. And then I'm going to multiply the whole result by 3. Okay, so this goes from 4 to 4 plus 2 to 3 times the quantity, 4 plus 2. And that's actually what we should have for a final result. So if I'm working this out, and I am, since I'm working the homework with you, we have 4 plus 2, so that's going to be, let's see, 4 plus 2 is 6. 6 times 3 is 18. So if I choose 4, I should get 18 as a result. So I can check these. If I think Alicia's right, 3 times n plus 2 turns into 3 times 4 plus 2. 3 times 4 is 12 plus 2 is 14. I should have gotten 18. I got 14. That tells me Alicia is not right. But I should probably check Brianna as well. So we have 3 times n plus 6. 3n changes into a 4 plus 6. 3 times 4 is 12. 12 plus 6 is 18. Brianna is actually correct. And that's how I'll support my case. I have my example right here. I have where I worked it out here. Those two examples combined with an explanation that she didn't distribute. Like that was her problem. When she multiplied by 3, she only multiplied the n times 3. And here you get to multiply both the n and the 2 by 3. That's the explanation we're looking for. Alicia and Brianna are at it again. Can you believe it? Okay. Okay, so who is correct? Well, let's just work an example. I'm going to choose a number. Let's make it 4. I chose 4 last time. Let's make it 2. Subtract 4 from that number. So 2 minus 4, and that's going to get me negative 2. And then I'll divide that by 2. So I have negative 2 divided by 2. That will equal negative 1. So I throw in 2. I get out 1. Okay, so who is right? Well, let's just check it out. Alicia, I'll put in green. So if I choose 2, I should get negative 1 as a result. So let's check out her expression. N minus 4 divided by 2. Put in 2 for the n. So 2 minus 4 divided by 2. 2 minus 4 is negative 2 divided by 2. That equals negative 1. That tells me Alicia is correct and Brianna is wrong, no matter what she put. Now let's examine these two expressions to see what went wrong. So here is kind of like a distribution problem. We have this n minus 4, and then we have to divide the whole result by 2. N minus 4 happens first, it's in the second step. Divide the whole thing by 2. That's why we have this fraction bar over the entire n minus 4 in parentheses. Now check this out. N minus 4 divided by 2, she did not divide both the n and the 4 minus 2. She just divided the 4 by 2, excuse me. So she's doing this wrong. If you have n minus 4 from the previous step, the entire n minus 4 must be carried and divided by 2. One last go. So what is it? What's the score? 1 to 1? The score is 1 to 1. Oh, so who's going to win? So again, I'm just going to jump right into my example. So I'm going to pick a number. Let's make it 10 this time. Subtract 4. 10 minus 4 is equal to 6. Multiply by 7. 6 times 7 is equal to 42. So if I put in 10, I should get 42 as a result. Let's check it out. Looks like Ashley's up first. Let's make it purple. Okay, so her expression is 7 n minus 4. Now this looks right to me because we have the n minus 4 and then multiplying the entire thing by 7, so it feels like it should be right. But let's try the example. We have 10 for our n, so 7, 10 minus 4. Now look at that, doesn't it look awful similar? 7 and 10 minus 4 is 6, that'd be 42. Hey, look, that worked. So Alicia is definitely correct in this one, but we shouldn't throw away Brianna's because hers kind of looks not bad either. Um, so again, let's take her expression and substitute values. I have 7n minus 28. Now we'll substitute in 10, so 7 times 10 minus 28. 7 times 10 is 70. Minus 28, wait a minute, that's also equal to 42. So they're both right in this one, no one's wrong. Let's try to figure out why, and I think to figure out why is going to be right here in comparing this creature with this creature. If you think about distribution, okay, and I'll get way in here so I can make my example. We have this 7n minus 4. Well, if I were to reorganize this using the distributive properties that we saw today, this would be 7n minus 7 times 4. But wait a minute, 7 times 4 is just 28, so this would be 7n minus 28. And if you compare that with that guy, boom, it's the same exact expression. So distribution actually explains that these two are the same. All right, let's move on. Use the distributive property to write in an equivalent form. So this is like that left-hand side, right-hand side thing. So we've been given the right-hand form. So now I need to kind of break this up into two pieces. The 6 is a thing getting distributed, being given to both things. In this case, the things are the 10 and the 25. Notice the addition. So this will turn into 6 times 10 plus 6 times 25. All right. Create an example based on a purchase at a candy store to model the expression part A. So when I'm looking at either one of these expressions, and I'll erase all this other stuff, you have to kind of notice that in either case, I'm buying 6 of something. Okay? And those two somethings cost 10 and 25 cents. So this could be where, let's see, Mike C, which is me, goes to the store to buy 12 pieces of candy. Six that cost 10 cents. Actually, you know what? Let's not make it sense. Let's go crazy. $10. And 6 that cost $25. It's expensive candy. We're at the mall. Okay, we have another one of these distribution problems, so let's rock into that. Here we have to notice what's being repeated in both. In the same way up here, this 6 out in front ended up being the repeated version in both. Going backwards, we have to notice that 12 is repeated, and then the 5 and the 10 are the things that receive the distribution. So when writing this as a single value, we'll put the 12 out in front, 5, notice is addition, plus 10, and that will be our undistributed form. Okay, then create an example based on making a purchase at a candy store to model the expression part C. Okay, so we can probably make a similar example. So Mike B went to the candy store. He bought 12 pieces each of candy that cost, let's make it crazy, 5 million and 10 million each. Expensive candy. Okay, we're going to skip part 3. Let's not worry about that. And let's just talk about the distributive property. Now, this is one I'm not going to write down, but we'll talk a little bit about it if you like. So the whole point of distributive property is that I have one thing that must be multiplied to two things. That's really it. So, for example, and I'll put the examples down here. So, for example, in this kind of problem, I have one thing, and in this case, that thing is this 6 that must be multiplied to two things. One being the 10, and then one being this 4. And that's really all distributive property is. So, this 6 gets multiplied to the 10, but also gets multiplied to the 4. And in a nutshell, that's really all distributive property is saying. I have one item that needs to be multiplied to two different items. So this gives us a different way to write it. Now, I know you're not seeing why we're writing like this, really carefully, but there is a reason. Trust that there is one. And then we'll work on this a little bit more tomorrow. Like, I know I'll see some of you guys during Eagle Hour. The rest we'll see during 4th Hour. You guys have an awesome night. Thank you so much for watching. If this helped, why don't you direct someone towards Edmodo, because that's where it's going. And I'll see you guys later.